Okay, so I just want to go over some of the ones in lecture because I know we already did it, but I just want to reiterate some things. So I know that square root of -1 equals I, right? I know that square root of -1 equals I. Well, can I say that negative square root of 3 is -1 times 3? I mean, isn't that the same thing? So by according to my rules of radicals, I can split this up to square root of -1 times square root of 3. Well, square root of -1 I've already defined as equaling I. So it's going to equal I square root 3. So if we move on to number 6, I can say that number 6 is going to be negative square root -1 times 11. And because what I did in number 5, I can say that that -1 is actually going to become an I. So I get negative I, because I still have this negative here, so I have to bring it down, square root 11. Then for number 7, well, isn't number 7 the same thing as saying square root of -1 times 50, right? Negative 50 is 50 times -1. So I can say that is I square root of 50. Well, 50 I know I can break down into 25 and 2, and 25 is 5 and 5. So according to Mama's house, my 5s are going to be able to come out. So then I'm going to have 5 times I square root, well, what's left? A 2. So I have a 2 in there. Then let's say for number 8, number 8 is negative square root -45. Well, I know that from all my pattern, I'm going to bring an I out to get that 45 to be positive. So I'm going to have a negative I square root 45. Well, 45 can be reduced to 9 and 5, and 9 can be reduced to 2 factors of 3 and 3. So if I have 3 and 3, these guys are going to come out, and my 5 is going to be left. I'm going to have negative 3i, because I still have a negative right there, so I do have to bring it down. And then I'm going to have a 5 left. So I have a 5 on the inside. So that is how you're able to reduce square roots into complex numbers. Well, let's now go into maybe multiplying complex numbers. So if I go into number 9, first I want to reduce. So the first thing that I want to do is reduce. So reduce first, meaning I'm going to get these into complex number form. I know that this is going to be I square root 3, and it's times I square root 5. Well, I times I on my outside, if I'm multiplying these, I have I times I, right? And then I have square root and everything in my house, which is 3 times 5. If I were to simplify this, I times I is I squared, square root 15. Well, if I am to simplify this more, I know that with my imaginary properties, I squared equals -1. I already proved that in lecture. Well, if I squared equals -1, I'm just going to replace this with -1. So it becomes -1 times square root 15, or fully reduced to negative square root 15. That would be my final answer. Now let's move on to number 10. Number 10, I'm going to reduce first into my complex form. So I have square root, I square root, not 30, but 36, times, well, square root of -1 is I. What's square root of 36? Square root of 36, if you want to break down, it becomes 6 and 6. I know this is a perfect square of 6 squared. But if you didn't know that, you could still break it down, and you realize that the 2's are going to come out and the 3's, and 2 times 3 equals 6. So I'm going to have I times I, which is I squared, times 6. Well, I squared I already defined as -1, so it's going to be -1 times 6, which gives you -6. All right? What about number 11? Number 11, I want to reduce first. Well, I know 8 can be reduced to 4 and 2, and 4 is 2 and 2. So 2 of my 2's are going to come out. So I have 2 square root 2, because you have your 2's coming out, so you'll have 1, 2 left in the house. So then what I'm going to want to do is I still have times square root negative 2. Okay, well let's look at this. I can reduce this guy, so I have 2 square root 2 times, well that's going to be an I square root 2. And now let's multiply what's on the outside of my house and what's on the inside. So on the inside I'm going to have 2 times I, and on the inside I'm going to have 2 times 2. Well, these 2's can come out. So then we're going to have 2I times 2, which can be reduced to 4I. That's your answer. Well, all right, let's look at number 12. By rules of rationals, I can put this all under one big fraction. So I have negative 125 divided by 5. Well, negative 125 actually just equals, negative 5. So the square root of negative 5 can be reduced with complex numbers. So I have an I square root 5. That's your answer. That's it. Okay, so now looking at number 13. Number 13 is no different. We're going to reduce first. So square root of negative 5 is just I square root 5. And then square root of negative 6 is just I square root 6. So I'm just going to multiply my outsides and multiply my insides. I times I is I squared. Then I have 5 times 6. Well, I squared is negative 1. So I'm going to have a negative, and 5 times 6 is 30. All right, well, number 14. Number 14 is no different. First of all, I have I, right? And then square root 9 times, well, square root of negative 1 is going to be I. But square root of 9 is actually a perfect square, right? It's 3 times 3. So I'm going to have 3I and then times another I. Well, it's going to become 3I squared. But I squared, as we said, I squared equals negative 1. So it's going to be 3 times negative 1, and that equals negative 3. What about number 15? Number 15, 125 is a pretty large number. I actually probably want to reduce that first. So 125, can split it up into 5 and 25. 25's two factors are 5 and 5. Well, that means I'm going to have 3 5's. 2 of them will come out. So I'm going to have 5 square root 5. And square root of negative 5 is actually I square root 5. So multiply our outsides and multiply our insides. I'm going to have 5 times I, and then square root of 5 times 5. Well, my 5's can come out. So then I'm going to have 5I times 5, which can be reduced to 25I. All right, well, what about number 16? Number 16, as I said before, we can completely combine everything under one big radical, which is negative 27 divided by 3. That actually reduces to, I don't know, negative 9? So square root of negative 9, that equals I square root of 9. Well, square root of 9 is a perfect square, right? Factor of 9 is 3 and 3. So it ends up being 3I. Well, now that we can rationalize complex numbers, let's just add and subtract them. They're no different. I's are like terms, right? So you're just combining like terms. Okay, so you're going to combine like terms. Now, just like an x value, if this was 3x plus 2x, you'd get 5x. That is the same thinking and way you're going to get with complex numbers. So 3i plus 2i, it's going to be 5i. So if I were to go to number 18, 18 is negative 4 minus 5i plus 2i. The things I can combine is negative 5i and 2i. So I still have negative 4. Well, what's negative 5i plus 2i? It's negative 3i. What about 19? 19, who can I combine? I only have one I, so that's kind of on its own. But negative 3 minus 7, that equals negative 10. And I can't combine anything more. There's nothing more to combine, so that's my answer. What about if we go on to number 20? Number 20 is 3i minus 8i. Okay, well, I can combine them. 3 minus 8 is going to be negative 5i. What about number 21? Number 21, there's two things I can combine, which is 3i and negative 12i, but 6 I can't combine with anything. So I'm going to keep my negative 6. And a positive 3i minus a 12i, that's going to give me a negative 9i. That's the most I can reduce it. I'm just simplifying these. I'm not solving them. I'm not trying to find an equation. I'm just simplifying. And so lastly, number 22. Well, 22, there's only one I, but I have two numbers, and I can combine them. So what's 5 minus 13? Negative 8. And I still have my negative 3i. So that is the basis for combining like terms when you have complex numbers.